So yeah, I was saying, do not be lazy. Don't be lazy on these types of questions. You should write out the whole equation. So this is the anode where oxidation happens. As we can see, aluminium is going from aluminium to aluminium 3 plus. From 0 to 3 plus, that's oxidation, and then from 2 plus to 0, that's reduction. So you need to write out the whole equation. So aluminium to become aluminium 3 plus, you guys know the procedure already. Plus 3 electrons. I'm not really good at writing stuff with this thing. And then you do the same for your nickel. Ni plus 2 electrons. Ni2 plus 2 electrons. And then you get your nickel. So you're going to multiply one equation by 3, the other equation by 2. That's what you miss if you try to do shortcuts. If you just exactly, some people will fail this just because they want to do shortcuts. You pick answer C or answer A just because you didn't want to write this down and multiply. So make sure you go the long way. Do it. I also got that one wrong because of that. So I just, my friends who might have done that as well, make sure. And then for this question now, well, nobody knows if it's always going to be CH or it might be something else. But if you get a question like this, where you have to calculate the empirical formula, we have H2O. We know that all the hydrogen from the hydrocarbon goes to H2O and all the carbon goes to CO2, right? So when you calculate the moles of H2O, don't forget that in 1 mole of H2O, I did this mistake. In 1 mole of H2O, you have 2 moles of hydrogen, right? So the moles of H2O that you're going to get, multiply by 2 to get the moles of hydrogen. Fine. In carbon, in 1 mole of carbon, you have 1 mole. In 1 mole of carbon dioxide, you have 1 mole of carbon and 2 moles of oxygen. Right? If we are given percentages and not masses like this, then you write your percentages in decimal form. That's how I do it. Like 20%, you write 0.2, and if the other thing is 80%, maybe that's 0.8, and maybe we're talking about hydrogen and fluorine. You write your percentages in decimal form like that, and then you divide by the AR of each atom. Hydrogen, the AR is almost 1. Fluorine, I don't know. I'm not holding a periodic table. Whatever it is, maybe it's 24. And then from there, you are now dividing by the lowest number to get the empirical formula. You guys know how to do that. This is what made me to fail the first time around. Make sure that if your compound is like H2O and you want the moles of hydrogen, 1 mole of water is 2 moles of hydrogen. Look out for stuff like that. I got it wrong once because I didn't look out for that. Then this limiting, which reactant is limiting, I bet everybody has the concept, but let me just give it to you once again. So what you're trying to do is to find out, well, let me use this reaction. We've got aluminium and Fe2O3. So the limiting reactant is the one that produces less product. Full stop. The one that produces less. The other one wants to keep on producing more, but then the other one is producing less. That's your limiting reactant. So you're going to choose one of the products. You want to find out how many grams of iron aluminium produces, or how many grams of iron Fe2O3 produces. So you need to choose one product. So you just don't say, I like aluminium oxide, so I'm gonna choose aluminium oxide, or Fe, it looks cool, I'm gonna choose Fe. You have to read the whole question. This is going to help you in the future. Look at C. They want you to calculate the percentage yield if the actual amount of iron produced is 167.6 grams. So they are concerned about iron, okay? So what do you do? A smart guy, people already figured this out, but let me just tell you, I didn't look at this, so helping those who haven't figured it out. in the last part of the question, they are going to be asking us about the ion produced. So you choose ion. Find out how many grams of ion aluminium produces and how many grams of ion Fe2O3 produces. Use ion, because in the end you're going to use that theoretical amount of ion that you calculated. You're going to need it in the end. So the one that they ask for in the end, use that one to find your limiting reactant. That's just one thing I learned. Here we go again. These quantum numbers are showing up again. For any energy level where d orbitals are permitted, speed s, p, d, and f. So d is 0, 1, 2, 2. How many d orbitals? The d orbitals range from -2 all the way to 2. So those are 5. -2, -1, 0, 1, and 2. Arrange in terms of increasing ion-associated energy. If you look at the periodic table from B to N, boron to nitrogen, we're going across the period. Yeah, people, you guys know this. You know that the first ion-associated energy is increasing as we move across the period. So the one with the most is the one that is going to be closer to the noble gases. Why? Because the nuclear charge is going up when the number of shells is remaining constant. In these types of questions, oh my god, please don't try to do shortcuts, okay? You're gonna get the reactants by, that inner outer trick, right? And then when you're now writing your net ionic equation, okay, so you're going to get, in this case, you're going to get lead, iodide, and sodium nitrate, right? So when you're writing your ionic equation, make sure that you do not decompose the solid, but everything else you should decompose it. Pb2 plus NO3 2 minus plus, and then you cancel out at the end. Don't try to do shortcuts because you might make a mistake. The same happens for here. This is an acid reacting with a base, so you're going to form H2O and salt. The salt is CH2, CH3, COONA. When you're now writing your net ionic equation, break down everything. Okay, don't try to do shortcuts. You already have the concept, so just don't try to do shortcuts. I tried to go straight from the molecular, from the, what do you call it? Yeah, from the molecular equation to the ionic equation, part B, and I got it wrong because it doesn't work that way. Okay. Part B, you might not predict proper results. So don't try to do shortcuts, right? Yeah. Because when it breaks down, you're going to have your CH3COO plus Na plus OH minus, giving you your CH3COO minus plus Na plus Na plus, and then the Nas are going to cancel out. You need to do everything. Yeah, everybody knows how to do this. You know how to calculate delta S. You make it the subject of the formula in your delta G is equals to H minus T delta S. Yeah, that part is covered. Okay, you know how to analyze your results. Now here is where I was also getting stuff wrong. Assume that, what are we calculating here? Osmotic pressure. Pi. I just have one thing I have to say about this thing. Pi is equals to M. And oh yeah, don't be scared. People, you already know that this formula is in the answers. So here, MRTI. Which value of R are you going to use? You're going to use that one, the 0.08, whatever. That's the one that you use in this case. When we're dealing with osmotic pressure, we use this R value. R has two values, 0.08 and the 8.31 something value. So you use the 0.08 when you're dealing with osmotic pressure, and also when you're converting, when you want to obtain Kp from Kc, that Kp is equals to Kc times RT to the power delta, and you use this R value as well. That was confusing me. You use this R value when you're dealing with osmotic pressure, and also when you're calculating Kp from Kc, you use this R value. Full stop. And here, yeah, people know how to go about this kind of questions. pH. Oh yeah, this stuff is not on the list of formula, so you have to know that pH is equals to negative log of H plus. People know that POH minus log of OH minus pH plus POH is equals to 14. pKa plus pKb is equals to 14. Ka times Kb is equals to 1 times 10 to the power minus 14. That constant is in the list of formula. Here we go. To which reaction occurs at the anode? Red cat. We go with our red cat. I'm not writing properly, but I mean to write red cat. Reduction happens at the cathode. So where is reduction happening? And also reduction is the gain of electrons. So this is your reduction. This is your oxidation. Why am I calling this reduction? Because this is plus, it's gaining electrons. This is losing electrons. So every time the electrons are on the left side, that is reduction. So which reaction is occurring at the anode? Reduction, cathode, red cat. So this is the cathode and that is the anode. Yeah, use that trick. Oh, it's not really a trick because people know it. And then this question, these cool questions where you have to calculate the EMF. Yeah, these questions are cool if you do them right. They can give you marks. So you have to use Nernst equation, right? Exactly. E is equals to E naught. And if the temperature is not at 25 degrees Celsius, you're going to use what I don't really know the equation by head, but it has RT in there. Yeah, exactly. Wait. Exactly. This is the thing you're going to use. So when you're dealing with this question, which value of R are you going to use? You're going to use 8.3145. 8.3145. And also when you're dealing with delta G, there's an equation. Yes, delta G is equals to minus RT ln K. You're going to use 8.31. 8.31. So when you're dealing with delta G and E, you're going to use 8.31. When you're dealing with the osmotic pressure and the conversion from Kp to Kc, for these two, you use 0.082. For these two, you use 8.31. Yeah, that's all. And yeah, one last thing. Oh my god, my time is running out. I can only go for 15 minutes. Why is this so small? When you're calculating the value of Q, that products over reactants thing in the last, where's the last question? Okay, we're still on the issue of Ernst equation, this one for calculating the ESO when the concentrations change. So when you're calculating Q, it's just like the equilibrium constant Kc with products over reactants, also raising them to the powers of their coefficients. But this question was interesting. Here we were given the pressure of hydrogen gas, the partial pressure of hydrogen gas, 0.04 atmospheres. So, well, you're supposed to write a balanced equation. So you're going to flip one of them to get a positive E naught cell. So you're going to have Fe. Yeah, when you're calculating your Q value for that equation, products over reactants, so you're going to include the partial pressure of the gases and then the concentrations of the aqueous solutions. We don't include liquids and solids. My whole point here is being that you should include the partial pressure of the gas. I didn't do that, and I don't want you guys to make the same mistake if we get something like this tomorrow. So good luck with not good luck. Luck doesn't. Okay, just good luck with the exam tomorrow, and make sure you don't make mistakes. The mistakes that I made, the ones I was talking about. And if I say some stuff wrong, please do comment in the section below. I also make mistakes. I may be wrong on some of the stuff I said. Okay, also a student.